Okay. Trigonometrical ratios. Is this the first time you're learning trigonometry in? Yes, ninth standard you're learning the first time, and then you're learning it in more detail in the 10th standard. Okay, this is the base for the 10th standard. Now, in this chapter, you have to understand about how a triangle works. Now, what type of a triangle is this? This is a right angle triangle. That means there's a 90-degree, and you have three sides. Okay, so other than the 90-degree, you have two angles. Now, we won't be looking at both the angles, but any one of the angle. Say we are looking at this angle here, we'll call that angle theta. Theta. Okay. Now this, we'll name this triangle as ABC. Okay. So angle C is theta. Now what is AC? AC is the longest side, which is taken as the hypotenuse. BC is the side that is next to the theta or adjacent to theta. Adjacent means next to. So we call the side as adjacent. And AB is the side which is opposite to theta. So we call this side opposite. Okay, so that's the name of the three sides. Hypotenuse is always fixed because it is the longest side. It is always opposite the 90 degrees. Adjacent will be next to the theta and opposite will be opposite theta. Okay. All right. Now, what if theta is on top here, or let's take it as alpha or some other angle? If this angle is alpha, then which is the angle adjacent to alpha? Which is the side adjacent to alpha? AB will be adjacent and BC would be opposite. So adjacent and opposite could be interchanged depending on where the angle is. But hypotenuse will never change. That is a fixed value. Is that clear, everyone? Now you have 6 trigonometrical functions called as, 3 of them are sine, cos, and tan. Have you heard of these? Have you seen it anywhere? If you have a scientific calculator, you will see those words sine, cos, and tan. You've seen it somewhere? Okay, so these are called the trigonometrical functions and they have some values. Trigonometry is not difficult. Just listen from the basics and it will be easy. Okay. Now there are some formulas here. Sine theta is equal to opposite upon hypotenuse. Cos theta is equal to, I'll show you a way to memorize it. I'm just writing the formulas for now. I'll show you how to memorize them. Okay. Cos theta is equal to adjacent upon hypotenuse, and tan theta is equal to opposite upon adjacent. Okay. Now what this means is, if you have opposite and hypotenuse, if you have these two sides, you can find theta. Or if you have theta and opposite, you can find hypotenuse. Or if you have theta and hypotenuse, you can find the opposite. So out of these three values, if you have any two, you can find the third value. Now always theta will be given and one of the two sides will be given. So you can find the other missing side. Okay. Always theta will be given, that is angle will be given, and one of the two sides, either opposite or hypotenuse, will be given. If opposite is given and if you have to find hypotenuse, we can find that. Okay. Now how to remember this? So there's an abbreviation. The abbreviation is like this. Some of her children are having trouble over algebra. All of you say this. Some of her children are having trouble over algebra. Okay. Say that. Some of her children are having trouble over algebra. Now why we are learning this? Look at the first alphabets. Sum of her, that is SOH. SOH. So sine theta is equal to opposite upon hypotenuse. Next, children are having CAH. What is that? Cos theta is equal to adjacent upon hypotenuse. And trouble over algebra, T. Tan theta is equal to opposite upon adjacent. Easy way to remember the formulas? Yeah, otherwise it will be a little difficult to remember. Johan, is that clear? Iba, is that clear? Okay. All right, just note down this much. All of you write down this much. Write down this. Okay, done. Now we have seen 3 trigonometrical functions. Those are sine, cos, and tan. But there's totally 6 of them. Okay. Now the remaining 3 are just the reciprocals of each of them. So I like to draw this table over here like this. And on top, we write the 3 that we have just learned: sine, cos, tan. Remember this: sine, cos, and tan. They are the main ones. Okay. Now the reciprocal of sine is cosec. Okay, cosec is a reciprocal of sine, which means like sine theta is opposite upon hypotenuse. Therefore, cosec theta will be what? Hypotenuse upon opposite. That's all. Reciprocal of sine. Okay. Reciprocal of cos is called sec. And reciprocal of tan is cot. Okay, now these are actually all the short forms. These words are actually longer. Like sec is actually secant, cot is cottoned, tan something. Okay, we don't use the full words anyway, huh? Yeah, we use anyway these words. These are short forms of it. Sine, we say sine, not sin, because the actual word is sine. Okay, so there's a e, so sine. So just sin, we say sine. Okay, so sine, cos, tan, cosec, sec, cot. So let me ask you, what is tan theta's formula? Tan theta is opposite upon adjacent. What is cot theta? Look at that. Cot theta is adjacent upon opposite. Sec theta, hypotenuse upon adjacent. Johan and Hiba, you're getting it right? And cosec theta, hypotenuse upon opposite. Okay. So if you want in an exam, you can just note these down, or you can remember it, or however you want. But somehow you have to draw this table. If you draw this table, you will get everything. Okay, right now draw this table. Sine, cos, tan, and their reciprocals. Okay, so you also need to know the Pythagoras theorem. Have you heard of the Pythagoras theorem? So the Pythagoras theorem is the relationship between the 3 sides of a right angle triangle. Okay, the relationship is like this. The hypotenuse. What's the hypotenuse? AC. So AC square is equal to sum of the other 2 sides squared. That means AB square plus BC square. This is the Pythagoras theorem. Write this down. Heading right, Pythagoras theorem, and write this down. Okay, that's the whole chapter. This is the whole chapter. This is what you're learning new in this chapter. Whatever else, anything else that's there is 877 questions. Okay, this is the new thing that you're doing in this chapter. Okay, so let's see what we're trying to find out. See, as I said, no, in this formula, 2 things will be given. That is the angle and one side. They're asking you, they'll be asking you to find the other side. See, when do we use the Pythagoras theorem again? When we have 2 sides, no angles. Just we have 2 sides and we find the third side. When do we use these formulas? If you have 1 angle and 1 side, then you can find the other side. So out of 3 sides, you only have 1 side and 1 angle. If you have 2 sides and you don't need these formulas, you can directly use Pythagoras theorem to find the third side. Okay, you can use this formula to find the angle if you have 2 sides, but in your syllabus, you don't have to find angles because that's a little complicated. You need a table called the inverse formulas, which I don't think you even have that table in the back of your book, but you will have it in 10th. Okay, so now it's just finding that one unknown side. Okay, all right, let's look at the first question. From the following figure, find the values of sine A, cos A. Okay, they're asking you to find sine A. Okay, let's see. So we have a triangle here. This is a right angle triangle, and they have given 2 sides, 4 and 3. We need to find the hypotenuse. Because we have 2 sides, you can find the hypotenuse using which formula? The Pythagoras formula. So we need to find AC. AC square is equal to AB square plus BC square. So AC square is equal to 3 square plus 4 square. That is 9 plus 16, which is 25. So AC, it will be square root of 25, right? Because AC square we have. Therefore, AC is 5. Okay, so we got the third side. So now since we have all the three sides, we can use any of these formulas. See, there was sine A, cos A, cot A, sec A, cosec C, tan C. Any of the six trigonometrical functions. And the angle C, look at the angles. Sometimes A, sometimes C. A or C. They will never ask B because B is fixed. B is 90 degrees. Right. So the formulas will either be for A or for C. Okay. So first question, find sine A. Now tell me, what's the formula for sine? Sine theta. Write down sine theta's formula. Sine theta is what? Yeah. Opposite upon hypotenuse. So now you write sine A is equal to, now look at A. From A, which is the opposite? Opposite is this, CB. So write the values BC upon hypotenuse, which is hypotenuse AC. So you can write this sine A is equal to 4 upon 5. That's the answer. Okay, we're finding sine A. We're not finding A. We're not finding the angle. They will never ask you to find A. They'll tell find sine A or something like that. Now, what does sine A mean? Like, there are values like sine 0 degree, from 0 degree till 360 degree, there are values for sine. Suppose I'm giving you an angle 30 degree. Okay, sine 30 degree has a value, cos 30 degree has another value, tan 30 degree has another value. So like that, there are values for everything. And the values range from 0 till infinity. It's like if I open a calculator, you will see the values. Okay, like sine values all range from 0 to 1. Okay, see sine. Now tell sine 1. Okay, sine 1 is how much? I have to put 1 and then sine. This is the value for sine 1. 1 meaning 1 degree. So sine 1 degree is this. So like that, there are values all the way from 0 till 1. For sine, it is 0 to 1. Everything is between 0 and 1. For cos, it is backwards, 1 to 0. It's the reverse of sine. And for tan, it is 0 till infinity. So like this, there are some numbers. Okay, their use and all, we don't learn till 10th why it is used. For now, it's just like you're converting every angle into a number. That's what these do. Okay, so we have done sine A. Now you do second one, cos A. What is cos A? What's the formula for cos? Hiba, tell me.
Cos is adjacent upon hypotenuse.
Okay, adjacent upon hypotenuse. So cos A is equal to, what is adjacent here? Johan, tell me.
Is it 4?
Adjacent to A, because it's cos A.
3.
3 upon hypotenuse, which is
5.
5, like that. Okay, so like that you can do all of them. You got it? Okay, write down, solve all of them. If there's only one angle, we call it theta. If there's two angles at the same time, we call one theta and one alpha, as I said. But they can use any Greek alphabet. But mostly there's only one angle, which is theta. Or you can just call it angle A or C, like here in this case. Come on, all of you solve all the 6. Hiba, any doubt?
No, sir.
Okay, you have to solve them.
Yes, sir, I did.
You solved everything?
No, sir, I have to just do cot A.
Yeah, cot A, and then sec C is there, and cosec C is there, tan C. There are 6 questions. Do all of them.
Sir, is cot A 3/4?
Is cot A 3/4? Yeah. Yes. See, if you're taking C as the angle, then BC is the adjacent. If you're taking A as your angle, then AB is the adjacent. See, because some questions have A, some have C, no? So wherever the question has A, then AB is the adjacent. If the question has C, CB is the adjacent. Okay, the other one is the opposite. Hypotenuse will never change. Adjacent and opposite will change based on what is the angle. Okay. What's cot A, everyone? Johan, you got?
Yes, sir, I got 3/4.
3/4. What about sec C? Bye-bye. Hiba, Johan, all of you, Adya, did you get? Bye. So for sec, sec is a reciprocal of cos. And what is cos formula? Children are having adjacent upon hypotenuse. So sec will be hypotenuse upon adjacent. Right, reciprocal of cos. That is what? Hypotenuse upon adjacent. So from C, look at C. From C, which is the hypotenuse? 5. Which is the adjacent? 4. What is cosec C?
Is it 5/3?
Yes. Okay. Johan, what did you get for tan C?
Sir, I got 3/4.
You said what? 4/3. Hiba, you said?
3/4.
Okay. All right. Okay, let me solve it. Most of you got 3/4. So tan formula is what? Children are having trouble over algebra. Opposite upon adjacent. So from C, what is opposite? Opposite to C is what? AB, that's 3. Upon adjacent, adjacent is what? 4. 3/4. Okay, now this whole exercise is like this, okay? They have triangles where you have to first use the Pythagoras formula to find out the missing sides, and then only you can apply these formulas. Okay, like look at the second question. From the following figure, find the values of cos B. Now look at the triangle here. What all sides do we have? Here, this is your right angle triangle. The right angle is here on top at A. This is B and C. So they have given two sides. One is 8 and 17. So first, using Pythagoras formula, you'll find AC. Okay. So AC square formula will be what? See, your Pythagoras formula is where BC is the subject. BC is the hypotenuse. So BC square is equal to addition of the other two. That is AB square plus AC square. Now we have to find AC. So if you make AC the subject, AC square is equal to, take AB square on the left. So you'll have BC square minus AB square. Basically hypotenuse minus the other side. AC is not the hypotenuse. So if you're finding any other side other than the hypotenuse, you have to do minus. If you have to find hypotenuse, you have to do plus. Okay. So AC square is equal to the hypotenuse minus the other side. That is 17 square minus 8 square. 17 square is how much? 289. Learn that in squares, no? Am I wrong? Is it correct? Wrong? 289? Okay. Let me just confirm. Yeah. So 289 minus 64. That is 225. AC square is 225. Therefore, AC is equal to 15. Okay, so we have all the three sides. Now we can apply the formulas. So cos B, you know how to do that, right? From B, tan C, from C. Now look at this more complex type of question, sin square B plus cos square B. So we're doing the third one directly. Sin square B plus cos square B. All right, so what is sin B? Sine formula is what? Sum of her. Opposite upon hypotenuse. And cos is children are having. Adjacent upon hypotenuse. I'm just writing this in brackets so that we know what to substitute. Now here, sine square b. So from b, opposite is 15. And hypotenuse is 17. So since it's square here, you also have to apply a square over here. Okay. Next, plus. From B, what is adjacent? 17 or 8? 17 is a hypotenuse. That will never change. So the adjacent to B is 8. Hypotenuse, 17. Whole square. Okay. And then you simply solve it like fractions. So 15 square is 225 plus 8 square is 64. And common denominator on both sides, 17 square, which is 289. So 225 plus 64 is 289. Divided by 289, answer is 1. Okay. All right. Later on, you'll be remembering this identity. It's like an identity. It's called trigonometric identity that you'll be learning either in 9th or 10th, where sine square theta plus cos square theta will be 1. Here we have just proved it. You take any angle over here, provided that both the angles are same. Say sine square 10 plus cos square 10. The answer will be what? It will be 1. Okay. But anyway, here we have to solve it this way. So like this, you can solve everything now. You understand? So write this one as an example and you can complete this as your homework. Note it down. Okay, we'll go to the next. You can complete that later. Just go down this much. That's enough. Now look at question 5. Given sine A is equal to 3 upon 5. Find tan A and cos A. There's no diagram here in this question. You see that? There's no diagram. They just gave sine A is 3 upon 5. What do you mean by that? What is it? What do you understand from that? Sine A is 3 upon 5. That's all that's given. So what do you think you should do? We're not using that identity. We don't have that right. Okay. We just have the sine A is equal to 3 upon 5. So we have to think of some of our children are having trouble over algebra again. What is sine formula? That means this 3 represents opposite and this 5 represents hypotenuse. Because sine theta is opposite upon hypotenuse. So then using these values, you will draw a right angle triangle. Okay. Say this is A, B, C. Don't take A as a 90 degree because A has to be an angle other than the 90 degree. So if A is your angle, 3 is the opposite. Which is opposite to A? BC. That is 3. And hypotenuse is 5. You see, we are able to draw a triangle from this. So now you find the missing value AB. What is AB? From the previous question we have seen. You see, this same type of question will come many times. You see these numbers? Very important. 3, 4 and hypotenuse will be 5. Okay. So anyway, you have to solve it. How do you solve this? BA square is equal to hypotenuse minus the other. That is 5 square minus 3 square. It's 25 minus 9, which is 16. Therefore, AB will be 4. You see, you got 4. Okay. Now, once you have all the 3 sides, you can find anything that's asked. See, they have asked to find tan A. Right. So, what is tan A? Opposite upon adjacent. What is opposite to A? 3. So 3 upon adjacent is 4. That's the answer. So like that, do you understand how to solve these type? So this is when there is no diagram. So then you draw the diagram with the 2 sides that are given and then find the third side and use that to find your missing values. Is that clear, everyone? Write this down. Okay, done. So look at this now. Here, what had they given? In this question, what was given? Sin A as a fraction. They gave a fraction. So numerator is one value, denominator is one value. Most of the questions will be like this. Look at the question 7. Here also. Cos A is 5 upon 13. Right? So if you know what is cos, then you know what's 5 and you know what's 13. We know two sides. Sometimes they won't give you a fraction. They'll give you something like the 10th question. Look at the 10th question. What they give? Cot A is equal to, there's no fraction. They gave what? 4 cot A is equal to 3. Where's the fraction? You need a fraction. So then what to do here? Yeah, take the 4 on the right side. So then we get cot A is equal to 3 upon 4. There we got a fraction. We have two sides of the triangle. We can do the rest. Understood? You heard me or not? There. So, and now some other times they won't even give like that. Like look at the 17th question. In the 17th question, what is given? Cosec theta is equal to root 5. That's it. There's just one number. There's nothing to take down. Then what do? We'll put upon 1. If there is no denominator, just put upon 1. So that way you have two values. So you have two sides of the triangle. Don't worry about what the values are. We can still solve. So let's try solving this now. Okay. Now what is cosec's formula? Cosec is the reciprocal of, wait, you have to think like this. Cosec is the reciprocal of sine. So sine is what? Opposite upon hypotenuse. So cosec will be hypotenuse upon opposite. Then you draw your triangle. Okay. If this is your theta, hypotenuse is where? Here. Hypotenuse is root 5 and opposite is 1. So opposite is over here. Okay, let's call this ABC. Okay, so what is Pythagoras' formula to find BC? BC square is equal to AC square, that is root 5 whole square minus 1 square. Right, we're finding not the hypotenuse, you have to minus. So root 5 square is what? It's 5 minus 1. So we got BC square is equal to 4. Therefore, BC is equal to 2. You see? Don't worry if square root is there because anyway you're squaring it, so that gets cut off. Okay. Now we have all the three sides, we can find whatever is asked. Okay, so see the first question. 2 minus sine square theta minus cos square theta. So that's 2 minus. Now here directly you can apply. What is sine square theta? Or what is sine theta's formula? Sine theta is opposite upon hypotenuse. So from theta, what is opposite? 1. Upon what's hypotenuse? Root 5. And it's a square, so square. Correct? Minus cos square theta. What is cos? Children are having adjacent upon hypotenuse squared. So that will be 2 minus 1 upon 5 minus 4 upon 5. Okay. So this 2 also multiplied with 5 because it's upon 1. So into 5, that will be 10 minus 1 minus 4 whole divided by 5. That's 5 upon 5, which is 1. So this is somewhat like the hard type of question from exercise A. Are you clear with it? Doable, right? Okay, write this down. And after this, we'll be stopping with trigonometry. Hiba, any doubt?
No, sir.
Johan, clear? Okay. All right. Easy? Just looking at the questions, do you have any confusion in any of the questions? Like, this is what we just did, right? 17. 18 is also similar. CK is root 2. So you'll take it as root 2 upon 1. Yep, you need a fraction. What about 19th one? Cot theta is 1. That means how to make it a fraction? 1 upon 1. Okay. No. 2. No. No. You try it out. Okay. So, yeah. So, if a fraction is not given, you make it a fraction. Clear? What about like this mixed fraction? Tan x is 1 upon 3. So, you convert this into an improper fraction. That is 3 ones are 3 plus 1, 4 upon 3. So, you have two sides, 4 and 3. Okay. All right. Now, this chapter has a few exercises. It has till E. And there are much more, like trigonometry is a very big chapter. It's one of the most confusing chapters in maths. But if you learn it from the basic, like from this chapter, and you do every chapter and practice every exercise, then it will be easy. Okay. So I think I don't know. I don't want to explain the next exercise because it will confuse you. You do this much first, then I'll explain the next. Okay. So we'll be stopping with maths. Okay, so this question number 2. Sine theta is given as 5 upon 13. Find sec theta plus tan theta. So this is just from the previous exercise. What are we supposed to do first when we have a fraction like this? What's the first step? So sine theta formula is what? Sum of her. Right, that is opposite upon hypotenuse. Sum of her. So then we draw a triangle. And in the triangle, we put the opposite. If this is your theta, we'll call this triangle ABC. If angle C is where the theta is, then opposite to that is AB, which would be 5, and the hypotenuse is 13. So we find BC using the Pythagoras formula. So BC square is equal to the hypotenuse, that is AC square, minus the other side, AB square. That's 13 square minus 5 square, which is 169 minus 25. That's 144, right? Therefore, BC is the square root of 144, which is 12. Once we get 12, we have all the three sides. So we can find sec theta plus tan theta. Now, what is sec theta formula? So before you do any sum from trigonometry, you draw this small table and keep. Always just draw this and keep. So you can just look at that whenever you have any doubt. Look at that. Okay, so sine, cos, tan. Reciprocals are cosec, sec, and cot. So you need sec theta. Sec is a reciprocal of cos. So you think, what is cos theta? So then you think sum of what children are having adjacent upon hypotenuse. So sec would be hypotenuse upon adjacent. Right. Then tan theta, trouble over algebra. That's opposite upon adjacent. Right there. And then in the next step, we substitute the values. So hypotenuse is 13 upon adjacent is 12. Opposite is 5 and adjacent is 12. So that is 13 plus 5, 18 upon 12, which is 3. Is that clear? Sorry, not 3, 3 upon 2. Or 1.5. Just check the answer behind. You want check the answer and see if it's 1.5. This is 19A question 2. The rest of you write it down.
Yes, sir, it's 1.5.
Okay. Write this down, and after writing this, do question 8 and 9. Johan, I want you to send me the solved paper, okay? I need to check your answer paper. When will you send it to me?
So I'll send it by tonight.
Okay. Okay, is everyone done writing this? Okay, we'll move on. Just before you start the 8th one, I want you to understand something. Look at the sides of this triangle ABC. Now here AB was 5, BC is 12, and AC is 13. These are not their actual values, okay? See, it's not like 5 centimeters or 12 centimeters. There's no unit for this. This 5, 12, 13, they're all a ratio. They're related to each other. See, when we write sine theta is 5 upon 13, see 5 and 13, they're ratios. It's not 5 centimeter and 13 centimeter. You understand? Now, when you say it's a ratio, that means, say we multiply both these numbers by 2 into 2 into 2. So we're getting what? 10 and 26. So it could be written as 10 and 26 also. You understand? They're not exact values here. They're ratios between each other. Okay. So that's very important. You have to keep that in mind, especially for the next question. Is that clear, everyone? These numbers are just relations to each other, just ratios to each other. Okay, question 8. Sine A is 3 upon 5. What does it mean? What is 3 and what is the 5? Sum of her, that is opposite upon hypotenuse. So in your triangle, if this is A, the opposite is 3 parts, okay, and the hypotenuse is 5 parts. Okay, and cos B is 12 upon 13. Now, I don't know, is it the same triangle or two different triangles? It has to be the same triangle. Okay, so first one was A, sine A, they taken A. Next is cos B. So which one should we, which vertex of the triangle should we take as B? We cannot take the right angle as B because we never mentioned the right angle as one of the theta, one of the angles. Okay, so that means B has to be here on top, and this is C. Okay, all right. Now, what is cos B? Cos B is 12 upon 13. Now, what is 12 and what is 13? Some of the children are having. So, children are having adjacent upon hypotenuse. If B is your angle, adjacent to that is 12. That means this is 12. Right? BC is adjacent. And hypotenuse is 13 over here. Okay, so it's confusing because there are already numbers that we have given here, and now we're adding more numbers. So I think what we do here is we will make two different triangles. Let's see if that works. Okay, so in your second triangle, let's take B as your main angle over here. So we won't add 12 and 13 here. We'll add it for a second triangle. Okay, so from B, adjacent is over here 12. The hypotenuse is 13. Okay, let's keep it like this. The other two sides, A and C. Okay, so from these triangles, find the missing side. Now tell me what's the missing value. We have already dealt with such numbers. If 3 and 5 are here, what is this side here? That will be 4, right? If hypotenuse is 5 and one side is 3, it's 4. You can go and check what we've done before. You'll get 4 anyway. Anyway, you have to do it, okay? You have to do it. You have to use the Pythagoras formula and find. And what about 13 and 12? What is AC? We have done like these questions also with the same numbers. What is AC? Just turn your page and see. 13 and 12 means what's the missing side? Let me show you. See here. Just now we did. 13 and 12 means the other value is 5. Okay? So we have these sides. Now evaluate sec square A. Okay, what is sec formula? Tell me.
Hypotenuse upon adjacent.
Hypotenuse upon adjacent. Okay, so you have for this triangle here, where A is your main angle, hypotenuse is 5, adjacent is 4. And since it's sec square A, you have to put a square. So the answer is 25 upon 60. Okay, similarly, do the second one also, tan A plus tan B. For tan A, you look at the first triangle. For tan B, you look at the second triangle. Come on, completed everyone? Anyone got the answer?
7/6.
7 upon 6.
Yes.
Check the answer behind.
Um,
Yes, sir, it's coming
yes, sir,
7
it was
upon
7/6.
The end is correct, no? You got? Adya? Yeah, I've written it on the screen. You can just take a screenshot or write it fast. We're going to the next topic. Okay. The next topic is called complementary angles. Write down the heading, complementary angles. Now, what is the meaning of complementary angles? What's complementary angles, Hiba? Have you heard this word before?
The angles that add up to 90 degree.
Okay. Complementary angles are angles that add up to 90 degrees. Okay. All right. Do I have all of your attention, Johan? Adya? Okay. Piper, where's the camera? Why is it off? Turn it on. Okay. So we have sine, cos, tan, our usual table, reciprocals, cosec, sec, and cot. Okay. Now, some of these, out of these 6 trigonometrical functions, 2 of them, two of each are complementary to each other. So those are there. See, sine and cos are complementary, tan and cot are complementary, and cosec and sec are complementary to each other. You see how I put these dashes here? Just to show which of these are complementary to each other. Sine and cos are complementary to each other, tan and cot are complementary, cosec and sec are complementary to each other. Now, what does it mean? It means sine 90 minus theta is equal to cos theta. Okay. What does this mean? It means if I have sine 80, for example, you see sine 80 can be written as sine 90 minus 10. Yes? In place of 80, I'm just writing it in the form of 90 minus. So sine 80 can be written as 90 minus 10. And according to these complementary angle ratios, sine 90 minus theta or sine 90 minus 10 can be written as cos theta or cos 10. Did you see that? Sine 80 can be written as cos 10 using this complementary angle formulas. Okay, is this clear, everyone? How sine 80 can be changed into cos 10? Okay, so that's what we'll be doing here in this part of this chapter. Okay, changing sine to cos or changing cos to sine. Okay, remember this is used to change sine to cos or cos to sine. Similarly, we can change tan into cot or cot into tan. Similarly, cosec can be changed to sec and sec can be changed into cosec. Okay, so I'm not writing all of them, but you can write 6 different formulas like this. You understand? The second one would be cos. Cos 90 minus theta would be what? Sin theta. In the same way, tan 90 minus theta is what? Tan 90 minus theta would be cot theta. And cot 90 minus theta would be tan theta. Similarly for cosec and sec also. Okay, I hope all of you have understood how these 6 formulas are there and how we can use them. Any doubt? Note this down, and if you have any doubt, please ask me. Okay, you done writing this? So I'll give you a question, you convert it to the other complementary ratio, complementary function. Okay. So if I have sec 50, how can we convert sec into whatever? What do we convert sec into? Sec converts into cosec. All right. So what's the first step is? We write sec as sec. Tell me. Hiba, tell me. What's the next step?
Sec minus theta will be cosec.
Yeah. So sec 50 will be written as what?
It will be cosec 90 minus theta.
So we don't use theta over here. We are using the angle. Okay, Hiba, turn the camera on. Johan, can you tell me how do we convert sec into cosec? What's the next step?
Not sure, sir.
Okay, look at this example here. Let's see the first example, everyone. I want you to be clear of the first example, then we can see more. Okay, so here we had a question which had sine 80. Okay, so what is first step is we're leaving the sign as it is. Sine, we're writing it as sine. 80, we're writing it as 90 minus something. Okay, so what is 80? 80 is 90 minus 10. Correct. 90 minus 10 is 80. And then we're using these formulas here. That is, your 10 is theta. Okay, remember that your 10 is your theta. So in place of sine 90 minus 10, we're writing cos 10. Do you understand that, everyone? Hiba, Johan, is that clear? So now, Johan, again, tell me what will we do for sec 50? Sec, you write it as sec itself. Tell me, Johan.
It will be converted to cosec, so
Before that, 50 will be written as 90 minus what?
40.
Yes, 90 minus 40. So now it's in the form of 90 minus theta. Okay. And then we'll convert sec into its complementary function, which is cosec. So what's the answer? Cosec
50.
40. Okay, you understood? The theta is the 40 now. Okay, so sec 90 minus theta is written as cosec theta. Okay. I'll give you a very easy way to solve this. Okay. You look at the question, the example 1, your question was sine 80 and your answer was cos 10. When you add 80 and 10, you will get what? You should get 90. Okay. See here in the second example also, sec was 50, cosec is 40. You see when we're adding them, we're getting 90. Yeah. So your question and answer, when you add the numbers, you will always get 90. And the sec will change into cosec. See here, sine changed to cos. So now you can even tell me the same thing in one step. For example, if I say cot 20, not cos, sorry, cot 20. What will cot 20 become? Tell me the last step.
Tan 70.
Yes, cot turns into tan and 20 and the number should add up to 90. So that is 70. Did you understand that? Adya, is that clear? Cot changes into tan and the 20 changes into 70 because when you add 20 and 70, you get 90. Okay. Now, what's the step in between? The step in between is where you leave cot as it is. Okay. And just change the 20 into what? 90 minus 70. That's the step in between. Is that clear? Okay. Write down these two examples. Okay. Done writing? So look at this small table that we have written here. We have seen so many relationships till now. There are many more, but till now, what all we have seen? We have seen top-down relations, vertical relations. They are the reciprocals, right? Sine and cosec are reciprocals. Cos and sec are reciprocal to each other. Tan and cot are reciprocal to each other. That was one relationship that we saw. The second relationship we have seen right now, that is sine and cos are complementary, tan and cot are complementary, cosec and sec are complementary to each other. Okay, so that's like the second set of formulas we can get from this small table. Whenever you're doing any sum, draw this table and mark these lines. Okay, what I've highlighted here. So that shows you which are the functions that are complementary to each other. Okay. All right, now a sum from your textbook, exercise 19A, question 1. Find sine theta, cos theta, and tan 90 minus theta. Okay. So here's the first time you're seeing 90 minus theta in a question. Now sine theta, you know how to solve. You know the formula. Cos theta also, you know the formula. Tan 90 minus theta. What do we do with tan 90 minus theta? We'll convert 90 minus theta into theta. So what is the complementary function to tan? Look at your table. Did you all draw this table? Here. What is complementary to tan is cot. Right. So you will write this as cot theta. It's the same. Right. Tan 90 minus theta is cot theta. Basically, you're just finding cot theta. Okay. All right. Now tell me the formulas. What was sine theta? All of you tell me. Sine theta is
Opposite upon hypotenuse.
cos theta. Adya?
Hypo upon opposite.
No.
Sorry, cos. Hypo upon adjacent. Sorry.
Children are having, no? Some of the children are having. Are having. Right. Adjacent upon hypotenuse. And cot. What is cot theta, Johan?
Sir, cot theta is adjacent upon opposite.
Yes. It's the reciprocal of tan. So adjacent upon opposite. Okay. Now look at your triangle. Only two sides are given. So you can find the missing side AB using Pythagoras formula first. So all of you do the sum right now. Find AB. Tell me what AB is first, and then put the values in these three formulas. Anyone? Yeah, just rejoin the meeting, everyone. And did anyone get AB?
16.
16. Anyone else? Okay, just rejoin everyone. Okay, so AB is coming square root of 256, which is 16. Once you have all the three sides, now you just write the values for all the three. Sine theta is equal to 16 upon 34, which is what? 8 upon 17. Cos theta, what's cos theta? 30 upon 34.
15 upon 17.
15 upon 17. And tan 90 minus theta, which is cot theta.
15.8.
Yes. Okay, we'll go to 19b now. We're using these same complementary angles here now. Okay, this is where you're mainly using these complementary angles. All right, so first question. I hope you're all done with this. Yeah. Okay, here. 19b. Find the angle theta in the following, where theta is between 0 degree and 90 degree. So what's given? Sine theta is equal to cos 75. So we need to find theta. So to do that, we have to make both the trigonometrical functions the same. Here on left side you have sine, right side you have cos. They should be same. Then you can cancel them out. So we will convert the cos into sine because we can. Right, sine and cos are complementary to each other. So leave the sine theta as it is. The cos theta, we have to convert it to sine. So the first step is what? Leave cos as it is. Write 75 as 90 minus what? What is 75? 90 minus? 90 minus 15.
15.
Yeah. And then in the next step, you're applying the trigonometrical ratio. So cos can be written as sine 15. Okay. So now since both are sine, therefore theta is equal to 15 degree. Do you understand how we did that? It's like we just cut off both the sines from both the sides. So theta is equal to 15. Adya, is this clear? What we are doing first step is making the trigonometrical functions same. Both sides should be sine or both sides should be cos. Yeah, and then we can do this. Write it down. Okay, let's try question 5. Tan theta upon 2 is equal to cot 20. Okay, so first thing we see tan and cot. Are they related? Tan and cot? Yes, they are the complementary angles, right? Tan and cot. So change one of them, either the tan to cot or the cot into tan. So let's leave tan as it is. Change the cot. So cot 20 can be written as cot 90 minus 70, right? And then cot can be converted into tan 70. Cut the tans, therefore theta is equal to 2 into 70. Okay, here theta cannot be more than 90. So the question says, you find the angle theta in the following if theta should be between 0 and 90. Okay. Just check the answer. What is the answer for this 19b question 1-5? Vaibhav, tell me the answer. Oh, this is not 20, it's 2 theta. Sorry. Question I wrote it wrong. It looked like a 20. See the question? Anyway, what's the answer?
So it's 36 degree.
Okay, so the question I wrote it wrong. It's not 20, it is 2 theta. Did you see that? Okay, so how do we solve this? 2 theta, what can we write this as? Just Vaibhav, just check your textbook. I don't have those pages. Just see an example.
Yes, sir, we have it. Should I send it to you?
Yeah, just send me a picture of that. I just suddenly forgot. All right, so we are directly applying the complementary angles. That is cot 2 theta can be written as the complementary angle to cot is tan. Right, so tan 90 minus 2 theta. Right, we're doing the reverse. Normally 90 minus theta was written as theta, but here we're writing theta as 90 minus theta. Is that clear, everyone? Cot, we're changing it to tan and applying that complementary angle formula. Okay. Let's suppose we have cot 90 minus, or say tan. Say we have tan 90 minus theta, or say 90 minus 2 theta. What do we write it as? We write it as cot 2 theta, right? So we're just doing the reverse. Cot 2 theta, we're writing it as tan 90 minus 2 theta. Is that clear? Okay, and now, since both are already tan, we cut off both the tans. Tan is cut off. So we have theta upon 2 is equal to 90 minus 2 theta. Then we take all the thetas to one side. So we'll take the 2 theta to the left. So we have theta upon 2 plus 2 theta is equal to 90. Then we just do normal addition of fractions. That is theta plus 4 theta whole divided by 2 is equal to 90. That's 5 theta is equal to 180. And theta is equal to 180 divided by 5, which is equal to 36 degrees. Is that clear, everyone? This is where we applied the formula, complementary angle formula.
So can you leave for something else? What should I do then? What's some?
Good, Bible?
Can I leave because I have another class or
Question number 2. Evaluate without using trigonometrical tables. Okay, now when we say trigonometrical table, we are talking about some values like sine, cos, tan, they have some values, and we will see what the tables are in one of these questions where we might need them. Okay, but now anyway, it's saying we do without the table, so we don't need to worry about that. Okay, so here, let's see the first question. 3 sine 23 degree upon cos 67 degree minus tan 64 degree upon cot 26 degree. Okay, so now we have to evaluate this, solve this, simplify this. So now look at this, look at the first trigonometrical functions. Here we have sine and cos, and we know that sine and cos are related to each other, right? They can be converted. Sine can be converted to cos, cos can be converted to sine. And the next two were tan and cot. Same way tan and cot also are related. So your aim here is to make them have the same functions. That means if numerator is sine, make the denominator also sine, or vice versa. That is, if the numerator is like if the denominator is cos, you make the numerator also cos. Like both should be same. Either both should be sine or both should be cos. That's the aim. Okay, make them same. One more thing to know that we can make them same is by looking at the numbers. Okay, here we have 23 and 67. When you add these numbers, what are we getting? 67 plus 23 is how much? It's 90. Right. Those angles should add up to 90. So that's a hint that we can make them same. Here also we have these two numbers, 64 and 26. Okay, they also, when you add them up, we get 90. All right. So let's leave the sign as it is, sine 23 as it is. We'll change the denominator. So cos 67 can be written as cos 90 minus 23. Right, because 67 plus 23 is 90. So 67 degree, we're writing it as 90 minus 23. In the next step, we can write that cos 90 minus 23 as what? As sine 23. You understand? We have applied the complementary angle formula over here. Cos 90 minus 23 is written as sine 23. So let's do the same thing for the second part also. Okay, so tan 64 degree, cot 26. So cot, we write it as cot 26 is written as cot 90 minus 64, right? Because 90 minus 64 is 26. In the next step, cot 90 minus theta can be written as tan theta. So it becomes tan 64. Do you all understand this step? What we did? First, cot 26 is written as what? Cot 90 minus 64. We have not changed the cot. We have left it as it is. Only 26 was written as 90 minus 64. In the next step, we have applied the complementary angle formula. That is cot 90 minus 64 is written as tan 64. Right? Cot and tan are related. Okay. Is everyone clear with this step? Now what next? We can cut. Sin 23, we can cut. Tan 64, we can cut. So what we have now in the numerator, we have 3 into 1. That's 3 minus 1. Answer is 2. See, your aim is to get them same in this case so that you can cut them and then you can solve it. Is this clear, everyone? Any doubt in this? Let me find a little more simpler question. Till then, you write down this one, solve this. I'll find another question. Okay, did you all finish? Hiba, is this clear?
Yes, sir.
Angie, this is the first class I think you've done this, but I don't know if you understood or not. How we use the 90 minus theta formulas. Is that clear, Angie?
Yes, sir.
Okay. So the idea or the thinking that you should have in your mind is if the two numbers add up to 90, right? If the two numbers add up to 90, then you make both the numbers same. Don't make the sign or cos or the function same, just make the numbers same. Something will happen. Okay. Like here in the first case, we had 23 and 67. When we add them up, we're getting 90. So what you should do? Make the numbers same. Instead of having 23 and 67, we had 23 and 23. Just try to make the numbers same. Then you'll be able to cut or you'll be able to do something with those functions. Okay. So let's look at the next question here. Question number 2. Cos 70 degree upon sine 20 degree plus cos 36 degree into cosec 54 degree. Don't worry about making the function same. Don't worry even if the functions are related to each other. Just focus on making the numbers same. Okay, keep that in mind. So like look here, yes, 70 and 20. Right, see when you add them up, you get 90. Right, so that is one set of numbers that you can make them same. The second set of numbers is 36 and 54. See, they also, when you add them up, you're getting 90. Okay, so solve it, try it on your own, try to make the numbers same, and then we'll see what happens. I'll give you 1 minute to start off, see if you're getting it. Okay, did anyone get anything? Okay, here, for those of you who didn't get, watch. So we saw that 70 and 20 add up to 90, which means we have to make them same. So cos 70, let's change the numerator this time. Okay, so we'll write it as cos 90 minus 20. Denominator, we leave it as it is. Don't apply the formulas in both, only on one of them. Okay, and over here also cos and cosec. Okay, let's change the cosec. We'll leave the cos 36 as it is. The cosec will change. So cosec 54 can be written as cosec 90 minus 36. Right? Because 90 minus 36 is 54. In the next step, you're applying the formulas. That is cos 90 minus 20 will become sine 20. Denominator is already sine 20. You see what happens? You're able to cut them off. You saw that? Okay. All right, and here cos 36 as it is, and cosec 90 minus 36. Cosec is reciprocal, complementary to sec, right? So cosec 90 minus 36 will become sec 36. How many of you got this much at least? Okay. See, we have made the number same. What after this now? The first fraction will become 1. What about here? Now, is there any relationship between cos and sec? Cos and sec. Look at cos and sec. They are reciprocals of each other. You see that? Which means cos 36 we leave as it is. Sec 36 we'll write it as its reciprocal. We can write it as 1 upon cos 36. You see that? Sec 36 we are writing it as 1 upon cos 36 because they are the reciprocals of each other. Now what do? We can cut them off. 36 and cos 36 and cos 36. So we have 1 plus 1. Answer is clear, everyone? Okay. All right, write this down and you will do the next one by yourself. Question number 3. I want you all to get the answers.
Sir, can you please explain it again?
Yes. Which part? Like, Aditya, turn your camera on first.
Like whole, cause
Whole thing yesterday we did know those 90 minus theta formulas. Do you remember those formulas?
yes,
Yes, we are applying those formulas. First thing is we see that the numbers, which numbers add up to 90. So 70 and 20 add up to 90. So we're using that formula for the cos 70 and changing cos 70 into sine 20. Okay, how? By first writing cos 70 as cos 90 minus 20. And then applying the formula cos 90 minus theta is sine theta. Okay. Then same thing we're doing also for this cosec 54. Cosec 54, we're writing it as cosec 90 minus 36. And then cosec 90 minus 36 becomes sec 36. Because cosec and sec are complementary to each other. And then for sec 36, we're writing it as 1 upon cos 36 because sec and cos are reciprocals of each other. So sec 36 can be written as 1 upon cos 36. That way we can cut the cos 36. Here we cut the sine 20s. Okay, so we have 1 plus 1. Answer is 2. Okay, question 3. Everyone solve it and tell me the answer.
So I take -1 for the third question. Should I send it?
Yeah, send it. Anyone else got the answer for the third one? Tell me. Okay, anyone else got the third answer? Vaibhav, Adya, turn your cameras on.
As -1.
Yes, you are correct. Johan, did you get it? Tell me if you got it. Angie? Okay, the ones who didn't get Angie, Adya, Johan. What's happening? Okay, see what we did. We made the numbers same. Okay, 52, 52, 65, 65, 55, 55. Okay, whichever numbers got added up to 90, we made them same. So after this, you can just easily cut them off. And what you have is 1 plus 1 minus 3, which is equal to minus 1. Okay, we'll do one last one from here, question number 8. Question number 8. Same rule.
Anna, how did we get 1 plus 1? I
How
didn't
did we get?
understand how we got 1.
When we cut them off, no? Anything that's same numerator and denominator, it becomes 1, right? For example, if you have 6 upon 6, and if you cut them, 6 ones are 6 ones are. It becomes 1, right? The same way, if numerator and denominator is the same, the fraction is 1.
Okay, thank you.
Yeah. Okay, anyone got the 8th one? You might need a little extra equations to be able to solve this. So did anyone come to a certain point and then get stuck, then not know what to do? Okay. All right. So all of you listen here. So we have already seen
So is
numbers
it
that
1?
1,
Yes, sir, I got the answer as 1.
yes, it's 1. Okay. So what did you do, Hiba? Tell me. You made the first two numbers same. So sine 32 and the cos 58 will become what? The cos 58, all of you? See, the numbers which become 90. Okay, I'm just marking those. These are the numbers which add up to 90. So those numbers you will change. Sine 32, we leave it as it is. Cos 58 can be written as sine 32. Right. You can do the same thing for this also. Now, see here the numbers are same as the previous one, 32, 58, 32, 58. So make the numbers all 32. Cos 32, we leave it as it is. Sine 58, we'll write it as cos 32. Okay, so now everything is 32. See, we made the numbers also same everywhere. And here tan, one tan we leave it as 20. The other tan we'll change it to its to its complementary angle. What's the complementary to tan? Complementary to tan is, if you're forgetting, draw this every time you're doing this. Okay, complementary to tan is cot. Okay, so tan 70 can be written as cot 20. Okay, numbers are same. What after this? Is this step correct? Clear for everyone? We match the numbers. We made the numbers same. Now sine 32 into sine 32 becomes what? Sine square 32. And cos 32 into cos 32 is cos square 32. Eba, did you do this?
Yes, sir. I used cos square 58, and then I got the answer as well.
And sine square 58.
Yes, sir.
Yeah, but then what did you do
Cos
after this?
after this, like our teacher in our school, she told us that like if it is anything, if it is sine square or cos square with any number, it will be equal to 1.
Okay, yeah. So that's what I have to teach you next. Okay. All right. So, okay. So here we have come to this point, sine square 32 plus cos square 32, and we don't know what to do unless you have learned it in school. Okay. So let me explain to you some identities. These are called trigonometrical identities or square relations. Okay. So just pause with this question. We'll see these identities and then we'll come back to this question. So these are the most important, okay, in trigonometry. So please listen very carefully. Always you have to write this small table, that is sine, cos, tan, and their reciprocals, which is cosec, sec, and cot. Okay. Now look at this very carefully. These are called square relations. We also call them as trigonometrical identities. Now in this, sine and cos are related. Okay. Tan and sec are related. And cosec and cot are related. See some weird relations. See what all are related to each other? Sine and cos, then tan and sec, and cosec and cot. Okay, so it's completely different relations over here. Okay, now how are they related? The relationship is between sine, cos, and 1. There's a number 1 also. Similarly, tan, sec, and 1. And the third relation is between cosec, cot, and 1. Okay. Now the first relationship is between sine, cos, and 1. In that, out of the three, sine, cos, and 1, one of them is always the biggest. So in the relationship between sine, cos, and 1, 1 is the biggest. Keep that in mind. What is biggest in sine, cos, and 1? 1 is the biggest. Okay. So the relationship is like this. Sine square theta plus cos square theta is equal to 1. Since 1 is the biggest, think of it like this. 1 is the biggest. So you have to add the other two to get 1. Okay. Now you can modify this one formula and make sine square theta the subject or even cos square theta the subject. Okay. Remember, 1 is the biggest. So let's say if you make sine square theta the subject. So sine square theta will be what? Take cos square theta on that side. That will be 1 minus cos square theta. Or similarly, if you make cos square theta the subject, cos square theta will be 1 minus sine square theta. Okay. So this one formula can be made into these three forms, where in the first formula 1 is a subject, in the second formula sine square theta is a subject, in the third formula cos square theta is the subject. Okay, so this is 1. All right, just rejoin the meeting, note this down and rejoin the meeting. So we saw sine and cos. We saw the relationship between sine, cos, and 1. In that, remember, what is the biggest? The biggest is 1. Okay. That's why if you see all the formulas, you can see clearly that 1 is the biggest. Right? In sine square theta plus cos square theta, when you're adding two small values, we're getting 1. That means 1 is the biggest. In the second one also, sine square theta is 1 minus cos square theta. 1 minus, because 1 is the biggest. So big minus small. The third equation also, cos square theta is 1 minus sine square theta, which means 1 is the biggest. Okay. Learn it. As you're writing it, please learn these identities or square relations. Okay, let's actually go back to our question and finish it off before seeing the remaining identities. So the first identity that we saw was sine square theta plus cos square theta can be written as 1, right? So we can apply that over here. Okay, let me write the denominators. So denominator tan 20 and cot 20, we can't do anything. So cot and tan, they are reciprocals. So cot 20 can be written as 1 upon tan 20. So that helps us to cut it out. Right? We can cut the tan 20 and the tan 20. Now look what happens to the numerator. Sine square 32 plus cos square 32. The 32 is the theta here. So sine square theta plus cos square theta becomes 1. And what's the denominator? That's also 1. So it's 1 divided by 1, which is 1. Is that clear, everyone? Okay, just complete writing that, and then we'll come back to the square relations. Okay, coming back to our square relationships. The next relationship is between what? Tan and sec and 1. Right, tan, sec, and 1. It's always 1 has to be there. Now in this, what is the biggest? Is it 1? No, it's not 1. It is sec. Okay, here sec is the biggest. So what will be your relationship? Since sec is the biggest, let's write sec as the subject. Sec square theta is equal to 1 plus tan square theta. See that? Since sec is the biggest, you have to add the other two to get sec. Got it? Now, if you make tan square theta the subject here, you'll have to take the 1 on the left, or you can think of it like the sec square theta is the biggest. So it is sec square theta minus 1. Okay. Or if you make 1 the subject, again, sec square theta is the biggest. So it is sec square theta minus tan square theta. Did you all get it? Those 3 equations from the first one. Remember like this, out of sec, tan and 1, which is the biggest? Sec is the biggest. So sec square theta is 1 plus tan square theta. Okay, that's your one identity that you have to get. Then the other 2 are just when you make tan square theta the subject and 1 the subject. Okay, write that down. Okay, we'll go to the last set of identities. That is between cosec and cot and 1. Now here, those of you who know, which one do you think is the biggest? Or if you want to guess, which one do you think is the biggest? Cosec, cot, or 1? 1? Vaibhav? Hiba, you know this, so what do you think? Which one is it? Do you remember?
Sine.
In cosec, cot, I'm talking about cosec, cot, and 1. In that. Okay, I'll tell you. The biggest is the biggest word. Okay, the biggest word is cosec. Yeah, cosec is the biggest. Okay, remember it like that. So what would be your first identity? Cosec square theta is equal to sum of the other 2. Cot square theta plus 1. Okay, or if you make cot square theta the subject, that would be cosec square theta minus 1. Because remember, cosec square theta is the biggest. It's always big minus small. Okay, or if you make 1 the subject, then 1 is equal to cosec square theta minus cot square theta. That's all the trigonometric identities or square relations. Is that clear, everyone? Okay, write this down. You will be using more of this only in the 10th standard, but you need to learn it now itself so that it becomes easy later on. If you have some, like in the previous question we had, right, sine square theta plus cos square theta, so we can use them. You won't have too many of these, but you still need to know them. Okay, write it down. See if you remember it, learn it. We'll do the next question. Okay, done. So there are so many different relationships between this sine, cos, tan, cosec, sec, and cot. Just to revise with you what all we saw. First, we saw the vertical relationships. Vertical means between sine and cosec, between cos and sec, between tan and cot. So what are the relationships between them? They are reciprocals of each other, right? Sine theta is 1 upon cosec, and so on. Then we saw the dash relation. Let's call it dash because we had put a dash here, right? This one, and this. Between sine and cos, between tan and cot, between cosec and sec. What were those relationships called? The dashed relationships are called complementary angles. Is that clear, everyone? Complementary angles, right? The 90 minus theta formulas. And then we saw this, what I've circled, right? Those relationships. Those were called what? They're called square relations. Is that clear? So like this, there are so many relationships between each of them, and drawing this table for every question in trigonometry will help you to easily solve them. You can just look and you can say, oh yeah, they're related. This is related. That's related. Like for example, if I ask you, try to answer, okay? How is cos and sec related? How is cos and sec related? What's your answer?
Reciprocal.
Yeah, they're reciprocals. So you can convert cos into sec, right? If you have cos 5, you can write it as 1 upon sec 5, right? That way we can convert cos into sec. Then how is cos and sine related?
Complementary.
Complementary angles. So suppose you have cos 5. How can you write cos 5 in terms of sine? Cos 5 can be written as sine what?
90 minus 1. So,
Yes, cos 90
oh,
minus 5, which is cos 85, right? So like that, you can convert cos into sine. You can also use the square relationships between cos and sine, because that is also another relationship, right? Cos square, but that you need a square. So if you have cos square 50, cos square 50 can be written as 1 minus sine square 50, right? From the square relationships that we saw here, cos square something can be written as 1 minus sine square that same angle. Okay, so like this, you have so many relationships between all these trigonometrical functions. Okay, all right, let's move on. Hmm. We also need to see the table now. So the question says here, evaluate without using trigonometrical tables. Okay, so what is this table? We will see that now. Question number 9, you have to use the table, I think, because I don't see a way of using it, solving it without using a table. Okay, so let's see the question 9, and we'll see why we need to use something called a table. Okay, so question number 9, cos 44 cosec 46 plus tan 30 tan 60 minus root 2 cos 45 plus tan square 60. Okay, so here, which all numbers add up to 90? Which all angles are complementary? Tell me. From all these numbers that are here, which all angles are complementary? Which all you can make them same? Here, 46 and 40, 44 and 46, right? They add up to 90. Okay, so we can make them same. Then we have 30 and 60. Those are also complementary. They add up to 90. And then what about the 45 and the 60? You see, they don't, nothing. You cannot add them up to 90 or anything. Okay. So for those numbers which cannot be added up to 90, there's a way to solve it using the trigonometrical tables. Okay. So now let's see this trigonometrical table. This is something that you have to memorize. Okay. So you have certain angles like, sine, cos, and tan, and you have certain angles like 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. You have to learn their values. Okay. So we're going to learn it now. As we are writing it, we're going to learn it. How many of you already know these values? Anyone? Vaibhav, have you done this in school? Trigonometry is over, right? Have you done this in school?
yes, so we did this table, but I don't remember the value.
Hiba, do you remember the values?
As sine theta was 0,
Sine 0,
by
you mean?
2.
Hmm.
Yeah, sine 0.
Huh.
For 30, it was 1 by 2.
Hmm.
For
Correct.
45, it was 1 by root.
Correct.
Root. And others I don't remember.
Okay. All right. So we're all going to learn it in the next 5 minutes. You're all going to know it. Okay. So listen very carefully. Hadia, focus here. All of you are here. All right. So sine 0 degree is 0. And the last value, sine 90 degree, is 1. Okay. So all these values are between 0 and 1. Okay. The smallest value, sine 0 degree, is 0. And sine 90 degrees, 1. Now, who gave these values? Someone gave the values. You can confirm it by taking any calculator, any scientific calculator, and let's try it here. Okay, so we have different trigonometrical functions here. So let's try this. Okay, sine 0. We have to put 0 first and then put sine. Okay. All right, so sine 0 is 0. Is that? Now let's put sine 90. Okay, 90 and then sine. You see this? Sine 90, how much is that? It's 1. Okay, so all the values from sine 0 till sine 90 are between 0 and 1. There's also a table in the back of the 10th standard maths textbook. I don't know if it's in the 9th standard book, but that table has all the values, not only 0 degree and 90 degree, but 0 degree, 1 degree, 2 degree, 3 degrees. For all the degrees, you have sines and cos and tans value. Okay. All right. Anyway, these are the important angles: 0 degree, 30 degree, 45, 60, and 90. So those we have to memorize. If it's any other angle, you can look at the table and get its value. All right. Okay, now listen here. Sine 0 degree is 0. Sine 30 degree is 1 upon 2. Memorize this. Sine 30 degree is 1 upon 2. That's half. Okay. Sine 45 degree is 1 upon root 2. Okay, 1 upon root 2 is a little bigger than 1 upon 2. So it's getting bigger and bigger. Okay. And sine 60 degree is root 3 by 2. All of you memorize this in the next 10 seconds. Just look at it, memorize it. We will write it later. Okay, just memorize it. I'm going to ask you. Okay, so what were the values? 0, 1 upon 2, 1 upon root 2, root 3 by 2, and 1. Is that clear, everyone? Okay, so let me ask you now. Okay, I'm covering this up. Johan, what is sine 45?
Sir, 1 upon root 2.
Vaibhav, what is sine 30?
So 1 upon 2.
Adya, what is sine 60?
Root 3 upon 2.
Anshi, what is sine 90?
1.
Okay, so all of you got it. Hiba, I hope you're there. You can turn your camera on. Is it working?
Yes, it's working.
Okay, it was not on. Okay. Now, cos values are very easy. It's just the reverse of sine. Reverse of sine. That means cos 0 would be 1. Okay. And then you just next cos 30 would be root 3 by 2. Cos 45 would be 1 upon root 2. Cos 60 is 1 upon 2. And cos 90 is 0. Okay, just the reverse of what we saw in the sine. Is that clear, everyone? Okay, write down this much. Make the table, write down this much, and as you're writing it, learn it. I'll ask you and then I'll show you 10. Okay, let me ask you all now. Hiba, what is cos 30 degree?
Root 3 by 2.
Angie, what is cos 90 degree? Cos 90 degree.
0.
Vaibhav, what is sine 60 degree?
1 upon, oh no, root 3 upon 2.
Johan, what is cos 30 degree?
Sir, root 3 upon 2.
Okay, as I call your name, just unmute your mic, okay? Don't wait for the question to get over. Adya, what is cos 0 degree?
1.
Okay, Angie, what is sine 90 degree?
1.
Vaibhav, what is cos 45 degree?
1 upon root 2.
Okay, so I think all of you have got the values of sine and cos, right? Okay, so remember this, sine is from 0 to 1. Cos is from 1 to 0. Okay, now tan is, okay, for this, I need to show you one more relationship between all this. Look at this. Between this, come to the small table again, sine, cos, and tan. Okay, so here there's a new relationship, that is tan theta is equal to sine theta upon cos theta. Okay, that is another new relationship that we should know. What is that? Tan theta is equal to sine theta upon cos theta. Very, very important. Okay, so if we have sine and cos, we can find tan just by dividing them. Okay, in the same way, cot also. Cot theta would be what? Cot theta would be cosec theta upon sec theta. You saw that? We'll call these the horizontal relationships. Okay, the horizontal relationships are this. Tan theta is sine upon cos, or sine theta upon cos theta, and cot theta is equal to cosec theta upon sec theta. Write this down. So we have seen vertical relationships and we have also seen horizontal relations. Okay, the vertical were the reciprocals, and these horizontals are this one, what we have written here for tan and cot. So we can use this now to find tan formula, tan values. Okay, tan. How do you find tan? You just do sine value divided by cos value. So to find tan 0 degree, you divide these two. That is 0 divided by 1. What is 0 divided by 1? That's 0. Right? Yeah, I'll not spoil this table. Let's write the answer only. On the side, I will do it here. 0 divided by 1 is 0. Okay. Now, what is tan 30 degree? Tan 30 is 1 upon 2 divided by root 3 upon 2. Okay. 1 upon 2 divided by root 3 upon 2. So how do we write this? 1 upon 2, and this division we'll write it as multiplication, reciprocal the base, reciprocal the denominator. So that will be 2 upon root 3. Correct? 1 upon 2 into 2 upon root 3. So here 2 and 2 gets cut. What do we have? We have 1 upon root 3. Is that clear, everyone? Or you can even look at this. See here, na? What you can cut is you can cut the 1 with the root 3 and the 2 with the 2. That's how cutting works when you have 4 levels, like, you know, a fraction in the numerator and a fraction in the denominator. So what we're doing is actually we're cutting the 2 and the 2. You see that, everyone? 2 and 2, and we cut, what we have? 1 upon root 3. Did you get it? Okay. Now from the next one, 45, 1 upon root 2 upon 1 upon root 2. So here also root 2 and root 2 gets cut off. And so the answer is just 1. Okay. Then the tan 60 degree, here again 2 and 2 we can cut. And so we have root 3 upon 1, which is just root 3. And lastly, tan 90 is 1 divided by 0. What is 1 divided by 0? You can't divide, right? You cannot divide anything with 0. So it is infinity. Okay, these are the values for tan. You see the values are ranging from 0 till infinity. The smallest value is 0. The biggest value is infinity. The middle value is 1. 1 upon root 3 is smaller than 1, and root 3 is bigger than 1. So it's an increasing order. Okay. Is that clear, everyone? Learn the values of tan. Write it down. Okay, let me ask you now. Everyone ready? Sure, all of you keep your mics unmute and just say out the answer, whoever gets it first. Yeah. All right. What's tan 0?
0.
Tan 90 degree?
Infinite.
Infinity.
Tan 30 degree?
1 by root 3.
Tan 60 degree?
Root 3.
3.
Root 3.
Cos 45 degree?
1 upon
1 mod 1 by root 2.
Sin 90 degree?
1.
Yeah.
Cos 60 degree?
1
1 by
upon
2.
2.
1 by 2. Okay. Sin 60 degree?
Root 3 by 2.
3 by 2.
Okay. Tan 45 degree?
1.
1.
1.
1.
Tan 30 degree?
1 upon root
1 by root 3.
3.
One by root 3. Yeah, correct. Yes. Okay, very good. See, you have learned the table now, right? Okay. So now let's go back to our previous question. Where do we use these values? See here, cos 45, tan 60. In these two places, since we can't make the numbers same, we have to use the values from the table. Even though the question is saying evaluate without using trigonometrical tables, in these two cases, you have to use the table because you have no option. Okay. But in this 30 and 60, there we don't use the table, even though we have the values. Right? We have the values for tan 30 and tan 60. So there's an option, there's a better way. We can make the numbers same. So we don't use the table over here. Okay. All right. So let's solve this now. Cos 45 and 46 can be made same. So cosec 46. What is the complementary angle to cosec 46? Look at your table, your tiny table here. This is very important. Cosec. See what's complementary to cosec? It's sec, right? So cosec 46 will eventually become sec 44. Yeah. There's a step in the middle where you write cosec 46 as cosec 90 minus 44. And then it becomes sec 44. Yeah, I'm skipping one step. Now, same way here also, tan 30, we leave it as it is. The tan 60, we will change that to its complementary angle. So tan 60 can be written as what? Look at the table. Tan, complementary angle to tan is cot. So we can write it as cot 30. Yep. Okay, and then here, root 2 as it is cos 45. Now, what is cos 45? For this, we look at the table, or you know the value. What's cos 45? Cos 45 is 1 upon root 2. Yep. And then tan square 60. So what's tan 60? Tan 60 is root 3. So that will be root 3 and there's a square. So you have to put root 3 square. Tan square 60 has to be written as root 3 square. All right. Okay. So here what happens now? Cos 44 and sec 44. What can we do with them? Are they related? Is cos and sec related? Cos and sec. Look at your tiny table here. Cos and sec are reciprocals. So we'll write cos 44 as it is, and sec 44 we'll write it as 1 upon cos 44. Similarly, tan 30 as it is, cot we'll write it as 1 upon tan 30. Here root 2 gets cut, so that becomes only 1. And here root 3 square becomes 3. Okay, so now we cut everything. Cos 44 gets cut, tan 30 gets cut. So what's remaining? 1 plus 1 minus 1 plus 3. Did you all see that? 1 plus 1 minus 1. 1 plus 1 is 2. 2 minus 1, 1. 1 plus 3. Answer is 4. Is that clear, everyone? Nadia, is it clear? Angie?
Yes or no?
Okay. All right. Write it down. I think we have seen the
Can I
whole
leave
theory. Who's this, Angie?
at 5:40?
540?
Yes.
Yeah, I'll leave you
Practice.
at that time. Write down. Yeah, write down this ninth sum. Finish it off. Okay. I hope you're all done writing this. There are 8, 9 questions here of the same type. Okay, complete them all as your homework. There's a question 3 also here, simplify. See, it's already 90 minus theta. So, sine 90 minus theta, you can replace it and write it as cos theta. So solve that also. You might be using the identities, the square relationships over there. So we have done the whole theory. This is the whole theory for trigonometry. And all the theories in this one small table here. You see that? In this one table, you have all the 4 sets of formulas. Like you have the vertical formulas, which are reciprocals. You have the horizontal formulas. You have the yellow line, which I've marked, which is the complementary angles. You have this brown or green circle, which I've done. Those are the square relations. Okay. So you have all the relationships in this one small diagram. So whenever you do any question related to trigonometry, you first draw this on the side. So you can just look at it and then you can figure out all the formulas that are there. Okay, everyone. Trigonometry is little difficult because of all the relationships it has, and you will not know when to use what. Okay, so this will only come with practice. So you have to try them out as your homework, practice them each question 2 or 3 times. Only then you'll be able to do this easily. Okay, because you'll waste your time in this. And if you don't understand it in 9th, then 10th becomes very difficult. Okay, so your homework 19B, that's your homework. Okay, everyone, please do this. I'll send it on the group right now if it's not there. And yeah, even 19C you can start doing. 19C is all using the table. Look at the values. You see the angles? Cos 0 degrees, sine 45 degree, tan 45. It's all one of these angles that are in the table. Okay, so you can try out 19C also. The whole of 19C is live. Okay, this chapter is quite easy now since you know all the formulas. So try out some questions from 19C, at least the first 6 questions. Okay, from the first page. All right, we'll end with this. And I'll see you all in the next class. Okay, bye everyone.